Hi, this is the Chapter 7 Linear Regression Analysis, and the first example is we want to derive the regression equations for prediction, and this is the BurgerKing example. Let's take a look at this the data file. So the Excel, so you can see I already copied the data file over here, total fats in gram, protein in gram, and this sets, both sets contains 122 data, and so for the Excel we want to derive the equation, the regression equation linear model, and one thing for the Excel is once we do the scatter plots, it will using x value first, y value second. So in this regression model, very important, we want to distinguish the response variable, which is y, and x variable, which is a predicting variable. And in Excel, very important, we want to put x in front of y. So I just copy this one to the next column. Control C, and then I just copy over here. And then we just use, this is x value, this is y value. So we just select column B and C. And then insert scatter plots, just a simple scatter plots, and this one we go. So we already see how to draw the trend line on this graph. So let's click this one. Once we do from very beginning, click once. We have this chart elements. Click this one, we go straight line. If we just click here, it will show a straight line, but we want to see if we have more options. It's basically we'll open this dialog. So on this dialog, the last icon down here, you see the last so the trend line options, we have a linear option, and then there is others. So we just we don't need others. We just choose linear. Trend line name, custom. You can change the value, and down here at the bottom, the second bottom, and we want to display equation and display r squared versus. So we want to show this value. So these two values, now you can see it's already in our graph. So just move this one up to this corner, and then usually I will change the color, make it more obvious, and then change the title versus protein. So look at this equation. We have this y equal to 0.9507x plus 6.6494, which is the same equation as this one, but this protein is just x, and fat here is y. So that's the way basically for this equation, we will see this one, the equation, we rate this equation is for every gram of the protein change value x, the total fats will increase, say increase 1 gram of protein, y will increase 0.95 gram. And that's the, for prediction, we get this x value multiplied by this one plus this one equal, give us the predicted value y. And the actual line give us for every x value, the predicted value should be here. And read this graph. Normally, once we have a linear model, and we see for this one, we want to see if it's a good fit to a linear model. So this one is a reasonably linear fit to the linear model, and it has a positive linear relationship. That means protein increases, then total fat will also increases. And several things we want to see y variable. In this case, we see total fat is the y variable. It's also called the response variable. And x variable in this case is the protein contents, and that's also kind of predict. And next we look at R square. So R square is basically equal to the square of the Pearson correlation coefficient. So remember we talk about the Pearson coefficient. So we just use the Pearson, search Pearson. So Pearson correlation, so that's basically this value. And then we select array 1 and array 2. Array 1. So we get this Pearson correlation effect coefficient, which is the R value, and R square, this value should be this value squared. So we go this one equal to this value square of 2. So you can see on the R square is basically is the same value as this one. So as we talk about R, is basically the Pearson correlation coefficient just describe how good this linear model. So sometimes we normally say 0.9 and above is a good fit. This is 0.789 close to 0.8. So this range is just we say a reasonably linear model. It's a reasonably linear model. And R square, another explanation of this R square is we basically we will say in this case we say 62.3%. So normally we use the percentage to describe R square value. So 62.3% of the all data values, 62.3% are good fit with this linear model. So that's basically our linear model can explain 62.3% of those data values. Of course, another 37.7%. That's basically we see this value, this amount of the points, the data cannot be explained by using this linear model, or we say this linear model does not explain those 37.7% of the data in this model. So next video we will talk a little bit more on the residue. As we already talked about, the residue is basically the predicted value of the x value 30, we have predicted the y value, and the actual value is this one. The difference between these two is called residue. So next video we will talk about more on regression model and the residue analysis. Thank you.